Hello, we are from Group B are going to present about distinguished air generation system and air distribution system. Aftercooler. After final compression, the air will be hot. When it cools, it will deposit water in considerable quantities in the airline system. The most effective way to remove the major part of this condensate is to subject the air to aftercooling immediately after compression. Air cool, consisting of a nest of tubes through which a compressed air flows and over which a forced draught of cool air is passed by means of a fan assembly. The outlet temperature of the cool compressed air should be approximately 15 above the ambient cooling air temperature. Water cool. A water-cooled aftercooler should ensure that the air discharge will be approximately 10 degrees Celsius above the temperature of the cooling water. An automatic drain attached to or integral with the aftercooler removes the accumulated condensation. Aftercoolers should be equipped with a safety valve, pressure gauge, and it is recommended that thermometer pockets for air and water are included. Air dryers. The condensate water enters into the air network through the air intake of the compressor. The relative air humidity is dependent on the air temperature and weather situation. The absolute humidity is the mass of water vapor which 1 meter cube of air can absorb at the respective temperature. The formula applies if the relative air humidity is specified in percent. Relative humidity equal to absolute humidity times 100% over saturation quantity. If the dew point is reached, the relative humidity will reach to 100%. Dew point. The dew point temperature is the temperature at which relative humidity is 100%. The low dew point, the more water will condense and reduce the amount entrapped in the air. Pressure dew point. To compare different type of drying system, the pressure dew point is the air temperature reached during drying at operating pressure. The pressure dew point of the dry air should be approx 2 to 3 degrees Celsius. Drying method. 1. Refrigerator or low temperature drying. 2nd. Adsorption drying, desiccant. 3rd. Adsorption deliquescent drying. And 4th. Membrane. Refrigerator or low temperature drying. The compressed air is passed through a heat exchanger system through which the refrigerator flows. The aim is to reduce the temperature of the air to a dew point which ensures that the water in the air condenses and drops out in the quantity required. The air entering the refrigerator dryer is pre-cooled in a heat exchanger by the escaping cool air. It is cooled in cooling unit to temperature between 2 and 5 degrees Celsius. The dried compressed air is filtered. Before the compressed air is output into the network, the air is heated to bring the air back into the ambient condition. Advantages of refrigerant type air dryers include low initial capital cost, relatively low operating cost, low maintenance, not damaged by oil in the air steam. Disadvantage of refrigerant type air dryers: limited dew point capability, indoor use only in geographic subject to freezing ambient temperatures. Adsorption deliquescent drying. The term adsorb refers to the action where a material is dissolved in and used up by the moisture. Use hygroscopic desiccant material, usually salt, which has a high affinity for water. The desiccant absorbs the water vapor and is dissolved in the liquid form. Hygroscopic materials are blended with ingredients to control the pH of the effluent and to prevent corrosion, caking, and channeling. The desiccant is consumed when moist air is passing through the dryer. The single tower deliquescent desiccant type dryer has no moving part and requires no power supply. Dries the air to a specific relative humidity rather than to a specific dew point. The principle of the absorption air dryer. The compressed air is forced through a drying agent such as dehydrated chalk, magnesium chloride which remains in solid form, lithium chloride or calcium chloride. The drying agent must be replenished at regular intervals as the dew point increases as a function of consumption of the salt during operation. The pressure dew point of 5 degrees Celsius at 7 bar is possible. The inlet temperature must not exceed 30 degrees Celsius. The chemicals involved are highly corrosive, necessitating carefully monitored filtering to ensure that a fine corrosive mist is not carried over to the pneumatic system. Advantages and disadvantages of single tower deliquescent dryers. Advantages: low initial capital and installation cost, low pressure drop, no moving parts, requires no electrical power, can be installed outdoors, can be used in hazardous, mobile, dirty and corrosive application. While for the disadvantage, limited suppression of dew point, desiccant bag must be refilled periodically 2 to 3 times per year, regular periodic maintenance, and then desiccant material can carry over into downstream piping if dryer is not drained regularly, and certain desiccant materials may have a damaging effect on downstream piping and equipment. Some desiccant materials are melt or fused together, caking, at temperature above 80 degrees Fahrenheit. Desiccant material is hygroscopic salts which can accelerate corrosion. Also called as deliquescent dryers, it uses chemical agents like phosphoric pentoxide and calcium chloride, urea, lithium as drying agents. The moisture in the compressed air chemically reacts with the drying agent. The agent dissolves to form a liquid compound which collects at the bottom of the dryer where it can be drained out. The deliquescent agent has to be replenished regularly as it gets consumed during the drying process. Adsorption desiccant drying. Regenerative desiccant dryers use a desiccant medium to absorb water vapor present in the compressed air stream. Term adsorb means that the moisture adheres to the desiccant, collecting in the thousands of small pores within each desiccant bead. A chemical such as silica gel or activated alumina in granular form is contained in a vertical chamber to physically absorb moisture from the compressed air passing through it. When the drying agent becomes saturated, it is generated by drying, heating, or as figured above, heatless by a flow of previously dried air. The composition of the desiccant is not changed and the moisture can be driven off during a process of regeneration. The principle of regenerative desiccant dryers. The desiccant in one tower dries the air from the compressor while the other one is being generated. Regeneration can be accomplished using a time cycle or on demand by measuring the temperature and the humidity in the desiccant towers or dew point of the air leaving the on-line tower. Note: the drying takes place at line pressure. The regeneration process takes place by expanding air to atmosphere over the desiccant beads. How desiccant dryer operate? The heatless desiccant dryer operates to maintain the compressed air at specified pressure. The dryer utilizes two vertical pressure vessels called dual towers filled with a desiccant. The compressed air passes through the desiccant bit before being distributed to plant. As the air passes through the desiccant, water vapor is removed from the air through adsorption. All generative desiccant dryer require protection from compressor lubricant. To protect downstream equipment from dust or fines, a particular filter should be installed downstream of any regenerative desiccant dryer. Between 10% until 20% of the dry air passes through orifice 02 and column 2 in reverse direction to reabsorb moisture from the desiccant to regenerate it. The regenerating airflow then goes to exhaust. The directional control valve is switched periodically by a timer to alternately allow the supply air to one column and regenerating the other to provide continuous dry air. Extremely low dew points are possible with this method, for example negative 40 degrees Celsius. A color indicator may be incorporated in the desiccant to monitor degree of saturation. Microfiltering is essential on the dryer outlet to prevent carryover of adsorbent mist. Advantage of desiccant type dryers. Very low dew points can be achieved without potential freeze-up. Moderate cost of operation for the dew points achieved. Heatless type can be designed to operate pneumatically for remote, mobile, or hazardous location. Disadvantage of desiccant type dryers. Relatively high initial capital cost. Purge air usually is required. Periodic replacement of the desiccant bed. Oil or salt can coat the desiccant material, rendering it useless if adequate pre-filtering is not maintained. Okay.
Oh, play je.
Membrane dryers commonly used for aspiration, such as nitrogen production for food storage and other applications. The structure of the membrane is such that molecules of certain gases able to pass through a semi-permeable nitrogen and leaving a concentration of the desired gas at the outlet generator. When used as dryer in a compressed air system, specially designed membranes allow water vapor, a gas, to pass through the membrane pores faster than the air, reducing the amount of water vapor in the airstream at the membrane dryers, suppressing the dew point. The dew point achieved normally 40 farad, but lower dew points to negative 40 farad can be achieved at the expense of additional purge air loss.
Compressed air is an easily storable source of energy which is used throughout the world. Unfortunately, a byproduct of compressed air is heat and moisture. Through compression, the relative amount of moisture for a given volume increases, oftentimes leaving you with compressed air that is saturated with water vapor or containing liquid water. Water and even elevated dew points in the compressed airstream can create a multitude of problems and must be removed to ensure trouble-free operation. Unlike traditional desiccant or refrigerant dryer systems that produce a fixed outlet dew point, Pentair's advanced membrane modules are designed to reduce the incoming air moisture concentration. Dew point suppression can be optimized based on required air quality. Fluid Pro is used in applications ranging from 20 degrees to 150 degrees Fahrenheit of dew point suppression. Fluid Pro membrane air dryers operate behind the scenes, offering dry compressed air without any moving parts. Humid compressed air enters the membrane air dryer module and the hollow fibers. The hollow fibers are permeable to water vapor while preventing the loss of valuable compressed air. Humidity is transferred through the patented helically wound fibers and leaves in the form of humid air.
Okay.
Lastly, the secret for creating the dry product air is the difference in moisture concentration between the decompressed dry purge air and the saturated inlet compressed air. A small amount of the product air is metered, decompressed, and directed to the outside of the hollow fibers as purge. This purge air is generated through our integrated precision control orifice or through an external valve and/or flow control device. Air removes moisture while in the gas phase. It is exhausted directly into the atmosphere, which eliminates the need to dispose of the liquid waste stream. The most common operating pressure for Fluid Pro is approximately 7 bar G or 100 psig, while use has been recorded as low as 4 bar G or 45 psig, up to 12 bar G or 180 psig. Higher pressures improve dehydration while lowering purge. Operating costs can be lowered by using a larger Fluid Pro model, generating a lower purge percentage. To find out how you can increase efficiency while lowering operating costs, contact us today.
Advantage and disadvantage of membrane dryers. Advantage: low installation cost, low operating cost, can be installed outdoors, can be used in hazardous atmospheres, no moving parts. While the disadvantage is limited to low capacity system, high purge air loss 15 to 20% to achieve required pressure dew points. Membranes may be fouled by all other contaminants. Summary of the drying technologies available. Aftercooler. Reduce the temperature and water content of the compressed air. Water traps. Remove bulk water condensed by the aftercooler. Drip legs. Control slopes of water and oil from system upsets. Coalescing filter. Remove aerosol, water and other liquids which bypass the water traps. Pressure reduction. Drying through expansion. Refrigeration. Drying to dew points of approximately 37 farad or 3 degrees Celsius. Chemical dryers. Reduce dew point by about 50 farad or 10 degrees Celsius. Desiccant dryers. Drying to dew points of approximately negative 40 degree farad to negative 100 farad or negative 40 degrees to negative 73 degrees. Membrane dryers, variable drying capabilities to approximately negative 40 farad or negative 40 degrees Celsius dew point. Mainline filter. A large capacity filter should be installed after the air receiver to remove contamination, oil vapors from the compressor and water from the air. This filter have a minimum pressure drop and the capability to remove oil vapor. A certain minimum pressure drop to function properly as the standard filter. The filter is generally a quick change cartridge type. Air treatment. Inlet filtering remove particles which can damage the air compressor. Next, there is need to dry the air to reduce humidity and lower the dew point. Normally, performed between the compressor and the receiver and is termed primary air treatment. Final treatment consists of further steps to remove moisture and dirt and the introduction of a fine oil mist to aid lubrication. Air treatment. Allergen, especially for food industries like dust and pollen, mold spore and bacteria. Oil. The compressor also contributes to the problem with wet particles, oil vapor and fine aerosol that leak pass glands and seals from the oil sump into the compression chamber. Such contamination in the air system can affect the efficient operation of various pneumatic devices, and over time it can damage them. Compressed air filters that are installed upstream of the air devices will remove most of these contaminants. Filters will also remove most liquid water from the airline. Coalescing oil removal and oil vapor removal filters should be used for application requiring high quality air. Moisture or atmospheric air contains some water vapor. The air is compressed. The water content for a given volume of air increases. Air flows through the compressed air line system. The water vapor condenses in the pipeline. Moisture also may freeze in piping and control lines with serious effects. Extends the service life of pneumatic components, prevents airline freeze up, and reduces project rejects. Summary of some of the problems that can be caused by moisture in compressed air: washing away required oils, rust and scale formation within pipelines and vessels, increased wear and maintenance of pneumatic devices, sluggish and inconsistent operation of air valves and cylinders, product spoilage in paint and other types of spraying, rusting of parts after blasting, freezing in exposed pipelines during cold weather. Conclusion: what we have presented so far in this presentation is what is air dehydration. We have learned about aftercoolers, air dryer, and main line filter. We also discussed about type of aftercooler, air dryer, and line filter. We have talked about the advantage and disadvantage. Okay then, thank you. Bye.